quickly do a video key for quiz 6 for my online OChem in the fall of 2025. Nope, it's spring. Spring 2025. This is a quiz over substitutions and eliminations. So we'll start with this first question. What mechanism would be favored by the following reaction? So again, just like last time, I'm looking at my nucleophile, and if it's a strong nucleophile, it favors those two reactions because the nucleophile is strong enough to push the leaving group out. Whereas if it's a weak nucleophile, it's going to favor those one reactions because their weak nucleophile will allow time and space for the leaving group to leave first before the nucleophile attacks. So we'll start with looking at our nucleophile, and this nucleophile is just water, so it's not negatively charged, so this is a weak nucleophile. So now we're deciding between SN1 and E1, and honestly these two are pretty hard to tell the difference between because they both have that same first step of the leaving group leaving. But bulky nucleophiles typically favor E1, and the other thing that favors E1 is heat. And we have heat here, so I think that these two things are going to lead me to believe that it's E1. So E1, an elimination reaction, so your leaving group would leave. Oh, I guess we don't have to go through the whole mechanism. So that's how I would get to E1. Oh, there we go. Justify your answer to question 1. Be sure to include considerations about nucleophile, electrophile, and any other reaction condition. So I would say something like, with a weak nucleophile, E1 and SN1 are favored. Heat favors E1 over SN1. And because we have a secondary nucleophile, a secondary electrophile, which you need that for the leaving group to be able to leave, secondary or tertiary. You can't have E1 or SN1 with primary. So even if all these things were true and it was a primary leaving group, if we had the same reaction conditions, heat and water with this structure, it would not go through an E1 reaction because the leaving group can't leave on that primary carbocation. So instead, this would favor E2 because of the heat. So it would just take more energy for the leaving group to actually be kicked out because it's a weak nucleophile. But because we have a secondary electrophile, we know that E1 is possible. So I have justified my answer, including nucleophile, electrophile, and the other reaction condition is heat. So that's why I believe that E1 is the reaction for that. Okay, next question. Did I miss anything? No, next question. For the reaction shown in question 1, are there any stereochemistry considerations? So for an E1 reaction, you will typically get the most stable the most stable alkene possible. So the question is, I would say yes, there are stereochemistry considerations because you would have to consider, will it be cis or trans? That's our stereochemistry for this one. And E1 will typically go trans because that is the most stable. So E1 will typically go trans, so we just have to make sure to consider that we're giving the trans product. Okay, the next question, are there any regiochemistry? So that's Hoffman versus Zaitsev. So when we have an elimination reaction, if it's a narrow nucleophile like water, the more stable, more substituted, more stable product is going to be favored. And so in this case, after our leaving group leaves, the first thing we have to consider is rearrangement would happen. So if our leaving group leaves, We have a carbocation right here. And then I guess the initial carbocation would be here, and then it would rearrange. And then you could either have your nucleophile take a hydrogen from here or from here. And you'd get two different alkenes. It could also take from this one over here, but there's symmetry. These two are the same, so you'd end up with the same product from either of those. So our two possible options are this or this. So this is the more substituted and more stable. So I would say that this would be favored by the narrow nucleophile. So to answer this question, I would say, are there regiochemistry considerations? Yes. Narrow nucleophile. So substituted product is favored. Okay. Next question. For the reaction in question 1, is there the possibility of rearrangement, and how do you know? So yes, there is a possibility for rearrangement because a carbocation is formed and it is adjacent to a more substituted carbon. And you have to consider there is a hydrogen available to shift. Because if we have a carbocation that forms next to this, a more substituted carbon, but you don't have a methyl. So if, for example, we had this, but we only had these ethyl groups that could switch, there's no hydrogen and there's no methyl, a rearrangement still isn't possible. So you have to think about all those. For the reaction in question 1, what is the name of the final product formed? So going back up to that reaction. So, I forgot to draw my methyl group right here. So this is the final product that's formed. So let's see. That would be 1, 2, 3, 4, 5. So it's pentane. And we have a 2-methyl pentane, but it's not pentane, it's 2-methyl pent-2-ene. Or you could say 2-methyl 2-pentene. Either one of those is fine. So 2-methyl 2-pentene. Or 2-methyl pent-2-ene. And then the other thing you have to consider is this E or Z? But actually, because these two groups are the same, we don't have to worry about that in this case. Okay. The next question, what reaction mechanism would be favored by the following reaction? Okay, so again, I'm looking at my nucleophile first. It's strong, so it's going to favor SN2 or E2. So it's the 2s, SN2 or E2. And again, of the things that favor E2, heat is a big one, so E2 would be the answer for that. And it also is on a suitable electrophile. The next one, this is a strong nucleophile, but we don't have heat, and it's a secondary leaving group. So I would say, if I'm looking at my nucleophile, it goes strong, so 2, SN2 or E2. And we don't have heat, and this is a narrow nucleophile, so that makes me think it's going to favor SN2. Okay, in your own words, describe the mechanism of an E2 reaction. It should say describe. Be sure to clarify if it's all in one step or multiple steps. So all in one step, a strong nucleophile abstracts a hydrogen from a carbon adjacent to the leaving group. Those electrons form a double bond. And leaving group is kicked out. Okay, I hope that was helpful for you. I know you don't have your quiz back yet, graded yet, but your feedback on at least a multiple choice should be available. And I'll have the grader, I'll get her this key as soon as possible so you can get your feedback before your exam on Friday. Good luck studying.